Quickly, the plan of this presentation, we'll discuss about why we need the Semantic Web, what it is, and also how we did it. So how we did it with Jahia 6.6 and in one of our client cases. The presentation, just a few words. So Adrien comes from Logibal, and I think you can present yourself quickly.
Okay, so my name is Adrien Mascio. I work for a company named Logibal, which is specialized in semantic web and scientific computing, and in Python, so I don't do Java, so I will just explain the semantic web part.
Okay, and myself, Thomas Delerm, I'm a web architect at Sigma, so we are working in integration of CMSs and hosting and software editor. So basically, why do we need to evolve in the web? Because if you remind of all times of the web, it was something like this. It was very ugly. You had many links, and you would navigate between pages through links. And then a few years later, you've got Web 2.0, which is a marketing name only to say that you have more social interaction in your websites. Okay, that's great, but it's not enough for us because it's very limiting for what you can do with your data, because all our presentation is going to be about your data, what you can do with it in a company or on a website. So with Web 2.0, all your databases, all your data are exposed to the web through APIs. And the big problem of APIs is that you cannot really gather all your data together to make a good search. So it's like on this picture, you can see you have many different silos, but they are disconnected. And another problem is you can query, you can have documents as results, you can have web pages, but it's not objects. You do not know what you get as result. It's data, it's a chunk of text, but it's not an object. And the question you can ask is, are my results correct? Is it up to date? Is it sure? You really don't know. And a person who is a customer of your company cannot know if your data is fresh. And it cannot know if your data is a good quality. It cannot know if you have a big text, what means every word in this text. So it's just a quick example which Renault demonstrated a few years ago. They have more than 10 at power 20 different combinations of cars you can buy. So it's huge, and obviously you cannot list them all on a website. It's just impossible, it's too much. And traditional Web 2.0 approach cannot answer this kind of problem. Another problem which I think is common for many people who administrate websites, it's cluttering of tags and cluttering of information, because everybody can type information. It's the era of social web, but you just have no control on what people are typing, so it can be a different orthography, it can be different meanings. And we have the example in France with our president, whose name is Hollande, and it's also the name of a cheese, it's also the name of a country. And you have no relationship between all these tags. So if you have two very close tags, you cannot say, oh, it's maybe the same meaning, or it's close. You just don't know. And in the end, you cannot answer queries like, okay, tell me I want 10 products on my website, producer must be Samsung, or maybe it's Korean, or maybe the price is under $50. It's just impossible. The good news is we have a solution, and it's a technical evolution, because every time you need to evolve in your web approach, you need a technical evolution. And for web, it was the links. For web 2.0, then we introduced APIs and the capacity to interact live with contents with AJAX requests. And now, for semantic properties, you can add this information on your data, and you can create linked data. And that's going to be a solution to some of the problems we have shown. And that's why Adrien is with me, and he's going to explain to you what the semantic web is about, and what you can technically do with it.
Okay, so I will start with some definitions. It's always a bit complicated to talk about semantic web, because semantic web seems always a bit magical and confusing. And actually, since a lot of researchers in a lot of fields like mathematics, logic, philosophy, even artificial intelligence, worked on semantic web, they tend to invent new terms, concepts, and make it sound really complex. But the essence of semantic web is really actually simple. It's just about data and how you can publish data rather than just documents in order to share data and reuse it across applications. So I'm going to start by trying to say what I think, well, at least it's my point of view, what semantic web is actually not. It will maybe this in a more or less far future, but right now, if you want to do semantic web, it's not natural language processing. It's not magic, of course, because you have to make it work just now. You don't have any image automatic processing. It's not a new protocol. It's just plain HTTP. You just have a few standards that help you modelize your data and expose them through the web. So we, as human beings, if I read this HTML snippet, because I'm a human and I have a few knowledge in HTML, I can understand that this is a page with a title which is semantic web, and I can make sense out of this text because I just learned to speak natural language. So for me, when I read semantic web is a worldwide network of data, it means something for me. But if a machine parses the same document, well, for the machine, even if it knows that it is HTML, the only thing that it can parse is that there is an H1 tag, so it's a title, okay, but inside is just blah, 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 blah. It just cannot do anything. The only thing relevant that is usable by the machine is actually the link. So all the idea is to transform the first document in a way that machines will be able to understand something out of your text without any language processing. So what we want is for the machine to understand that in the previous snippet, this sentence, there are a few concepts in this snippet, and we want the machine to understand that semantic web is a network. Semantic web was created by Tim Berners-Lee, and semantic web was invented in 1994. So how can we transform this text into something that the machine will be able to process and understand this? Well, you have basically two ways to do this. The first way is to annotate your document. So I will show an example. And the second way is to publish explicit data. So the easiest way is to annotate your document and say use RDFA or schema.org or Open Graph or whatever. This is an example with schema.org of the same HTML snippet, the same one, the same tags, but with what we call microdata in it, and with annotations in a schema.org fashion, so that the machine will be now able to understand that you're talking about a certain concept, whose name is Semantic Web, whose description is Worldwide Network of Data, and whose creator is Tim Berners-Lee. And this is the easiest possible way to help your machine understand this. But of course, you have to know what a concept is, so this you have to refer to schema.org to know which classes and properties are available in schema.org. And you cannot, you know that there is something called Semantic Web, but you cannot give really sense to these words. So again, we don't want to make natural language processing. At this point, we could do maybe some entity recognitions, but I don't want to talk about this. So the other way is to publish another form of your document in RDF. I will explain what RDF is later. And the idea is to provide this document and make it accessible with just plain HTTP content negotiation. So your HTTP client will ask for the same URL and will ask, rather than HTML, we ask for RDF. RDF is just a description framework that helps you describe data in very simple statements. It's just basically really simple sentences with just a subject, a verb, which we call a predicate because it's logic, it's complicated, and so we don't call that a verb, we call that predicate, and an object, so subject, predicate, object. And this is a way to serialize RDF, which we call the turtle way, but you can serialize it in XML or there are other formats available. And this states that http://mysite.com/semanticweb is a SCOS concept that is closely linked to another URL and whose creator is Tim Berners-Lee and the date of creation is 1994. So the whole point here is to designate everything through a URL. I mean, if you make a parallel with a relational database, if you need to talk about a record in a relational database, you use a primary key, and then you use it in, for example, foreign keys. In the Semantic Web, you will use the primary key is a simple URL. So here, the kind of primary key is http://mysite.com/semanticweb. And then each subject of your sentences will always be URLs. And each object will either be plain text like 1994 or other URLs. The advantage of URLs, is that you can dereference them. You can just do a plain HTTP GET to get information about it. And then the machine can do that, and the machine can understand things about what you're trying to say. The other particularity is that, for example, there is something called SCOS close match. So how can I know what SCOS close match mean? Well, I can just Google it, and then I will probably land on a page of the W3C, and we'll have some information about that. But all the predicates, so all the properties, A, close match, creator, and date, are also URLs. They are encoded in a special way, but it's just URL. So if you want to get some information about it, you just have to make a simple GET, and you will HTTP GET, and you will have some information about it. So each term is a URL, each subject, and each property at least. So the idea is not only then to publish your data, but also to publish your data model. And this is a key point of Semantic Web, is to publish everything through URLs and then to publish your data model also, so that a machine can read the data model and can figure out what it can do with it. So all the difficulty is to know what data model you will use, and there are a few terms for that. We call that ontologies, but it's a complicated term. It's just plain data model. So you have to expose your data and your data model. You can do that very easily with any system actually which rely, for instance, on a relational database, because if your data is structured on the first place, it's really easy to just republish it in another format. So HTML is a format, but RDF is just another format. So it's really easy to republish your data in just another format. So it's easy for you just right now to say, okay, I'm not going to only publish HTML, I will also publish my data in such a standard way that some machines will be able to read and parse it. So it's standardized by the W3C. There's a bunch of standards associated to RDF and Semantic Web. I can provide you links if you need. What you can do right now, what can it provide to you? If you provide data, if you annotate your document, if you publish data, you will help search engines to parse your page and then to provide better search results and better page ranks. So better page rank is always good for your website. And you will also use external data integration, which means if you, for example, nowadays it's always about open data, and open data is great, but most of the time you just get a CSV or an Excel file. But if you don't know what each column means, you just simply don't know what you can do with it. So the whole idea of Semantic Web is to structure your data and explain what everything is. And just a few examples. This is a result from Google. And you will see that you will see annotations on some results. For the first one is the stars and the price and the availability is just information that Google have parsed from good relations annotations. So it's another vocabulary. So Google parsed it and then is able to restate the information on the web page. And the second one is just another one, just another example of schema.org parsing and annotations. So it will help search engines to get back and get better results on the web page. So now Thomas will explain just how he used all these technologies in his project.
Okay, thank you, Adrien. So yes, we have talked about Semantic Web, but not just for the fun, but because we've used it with Jahia and that it works perfectly. And that's what we are going to see. So one of our clients, whose name is BPI, so it's a huge library in France. They had some needs about Semantic Web. They wanted to expose their data better. And the three main needs when you do Semantic Web are about the input, about storing, and about the output. So input because you need to be able to add some information on your data and be able to give more details about what you are publishing. You need to storing in a friendly way which can be easily exposed, so in an RDF friendly manner. And then you need to output it, so you need to output it on every page if you want it to be used for SEO. And you need to output it in searches or in exports also if you want to exchange this data with your partners, with your business clients, etc. And the good news is we've done all this with Jahia. So why, of course, Jahia is a good choice for Semantic Web? It's that because for each of these needs you have an answer. You have an answer for input because Jahia is based on CND files for definitions, and because you have inheritance for your different content types, then it's easy to know what you are talking about. And it's a big difference because in some other CMSs, you're not so much content-centric, and Jahia is content-centric. Also, you need to enrich your data, and this you can do easily with CKEditor, so we'll show later how we did this. And also, of course, you need to add some information on your content directly, and we do this through the normal Jahia edition mode, so in GWT. About storage, a good thing with Jahia is that it's stored in a hierarchy, and as you know, in a hierarchy you can mix different types of data and just refer to them through their content node type and also through their place in the hierarchy. And that's very useful for Semantic Web because it allows you to classify all your data and also to add some metadata on it. And something which is going to be even better with Jahia 7 is that because you have external data providers, you'll be able to gather all your data in Jahia and then to expose it with the same annotation like schema.org or the other ones whose Adrien told you about. And the output, because also you can create new views and you can have different kind of exports for your data, then it's also easy to publish your data in a Semantic Web way. So how we did it in this project, it's a bit more technical, but it's some tips which we have learned from this experience. So first you need to make sure, of course, your text data is stored as HTML because you want to be able to add some metadata and some schema.org or other semantic languages on it. We needed also to add in-content data. For example, if you have a text which says, I'm going to the restaurant and the restaurant name is the best place in Paris, then you need to say the best place in Paris is your restaurant name, so you need to annotate your content. We also had the triple categorization of content, so that was a wish of our client, which proved to be useful because it's different level of categorization. You have the in-house categorization of Jahia, which is a closed list. You have tags, which everyone knows. And we have a third layer of categorization, which is based on authorities, which is something more specific to libraries. And it's linked to the BNF, and it allows you to say, okay, I'm talking about Victor Hugo, and it's a writer, and it's not a street which has this name or something else. And we still have other questions which are open about, okay, maybe we could store data in a better way, in a triple store. So it's a special database which allows you to store data in a triplet like Adrien told. Maybe we could create new algorithm to add semantics information automatically. That's complex, so we didn't go through this. Then for the content structure also, we wanted to be able to easily expose data and know which data is stored where. So we have decided to store every different node type in a separate node. So directories are organized per category. And we made sure also that the contributor does not need to fill any additional field, like everything is typing, title, name, link, etc. It's automatically translated to some semantic mapping. And for this, we use a properties file. So we have some kind of configuration which says, okay, title in my node type person is going to be published as this keyword or this tag. We also had to solve a few challenges, like how to store metadata in a file, and Jahia is also good for this because you can extend the GNT file and you can add some metadata about your file and then you can expose it. Or how to create a sub-content, because the important part is, okay, I want to expose my data. I have, for example, some regions, and inside my regions I have departments in France. I need to be able to say a department is part of a region, and Jahia allows this with inheritance and with node types. And we wanted to be able to create a new department inside a region. And here we needed to modify Spring GWT XML and add this new content button. Just quickly, because it's more for your reference, we've used different type of vocabularies, which we have all exposed on the pages. And of course, you do not want to expose every vocabulary everywhere, because it wouldn't make sense to expose a list of different contents like result, search results, which mixes persons or documents or other type of objects. So you wouldn't add metadata on it. But sometimes it's very important, and especially on the detailed pages, because on a detailed page you are going to explain, okay, it's a biography of a person. I want to know his date of birth, his place of birth, the books he's written, etc. So here you're going to use semantic webs. The output, we've done it in RDFA, it's a choice, so it can be debated. What's interesting again is that we've done a mapping between every field and the properties in other vocabularies, and it allows to provide this data to Google, and Google is using them for SEO. And also, Adrien was talking about URIs, so we have implemented something which is called AR key, and AR keys are some kind of unique URLs which allow you to answer a common problem of the web, which is you publish a document, somebody is making a link to your document, and 3 years later you come back, and of course the link has changed and the link is lost. And with ARK URIs, you make sure that the URI is never going to change. So that's very important when you want to keep track of your data, and especially, let's say, on Wikipedia, for example. And just to open up the mind and think what can be next in this area of semantic web, many evolutions are going to take place soon, or late, because maybe it's going to be 10 more years, but we always hope it's going to be soon. The idea behind this scheme is to say, okay, you have separate data in your company, and if you try to create a big database with semantic data, maybe you will realize that in your CRM, in your files, in your ERP, you have persons, you have authors, you have places, and you want to organize your data according to their type and not according to where they are used, which is what we do now. So it's quite a different way of thinking, and it can lead to expose more easily your data on the web. Also, the future, it's somehow right now, because if you look at Facebook, for instance, in the last few months, they made different evolutions of the platform, and they are trying to promote more and more all the posts which contain open data, open graph, sorry. And Open Graph is a proprietary vocabulary which Facebook created. And as you can see, the image, the text on the right column, they all come from Open Graph, because the site which publishes the content has these tags. So Facebook can read it, and then it can take the correct photo and the correct text. And that's very important. And in the future, that's going to be far away, but we hope that every document is not going to be tagged by yourself or tagged by on the photo, but it will be tagged automatically by a scan, and metadata is going to be added and categorized properly, etc. So it's just a dream at the current times, of course. But the real world for now is that semantic web is real. You can use it now, you can improve your ranking now, you can use Jahia to do this. And with Jahia 7, you're going to be able to make external data providers and make sure all your data is gathered and organized correctly. And because, it's a joke, but you know, when we say if you're not paying for a product, you are the product, so that's what we say about Facebook or Google. And the internet giants are not waiting to implement semantic web, because they need it and they want you to use it, because it will make their job easier to know what you publish and how they can give the results to people looking for you. So that's the only advice we can give, is go and try to add this data and these semantic web tags. So if you have any question for Adrien or for myself. Yes?
Yeah, I have several questions. Because you showed you have just like a folder structure and you map the title to different meanings. Why don't you have like different node types? So why do you have like the same objects and then map them to property files? So why don't you have like different node types for different?
No, there are indeed different node types. We have different node types for authors, for books and libraries and etc. And we have a different mapping for every node type. In fact, it's not just one giant object.
You just reuse the property. You don't have like different properties for it.
Yes, it's just technical. We have a big property file with all the mappings because more often, if you have a field name author in your author object and you have another field name author in, I don't know, a book, obviously it's going to be the same mapping. So it's easier to have one mapping file because it's the same mapping in every object. It's more logical. And we created the project like this to make sure we use the same word in two different contents when it's the same meaning.
When you said about CKEditor, you will show us how you use that because it was not shown afterwards.
Yeah, maybe I went too quick. Normally there was some, I don't know if I can find it, but there was a screenshot. I think it's this one. So I'm not sure it appears because it's very small, but we have added some buttons. And when you click on a button, you have a little pop-up which is displayed and says, okay, what do you want to add? It's a place, it's a person, etc. And what is the content? And first, of course, you double-click on the text you want to tag, and it's going to add this semantic data on what you have selected.
And where do you get it from? Like,
it's user input, and that's why I said it's a lot of work, and we are thinking of how can we input this in a more automatic way, because it's very long to do. Okay, thank you.